What about electron affinity? The electron affinity of an atom or molecule is defined as the amount of energy released when an electron is attached to a neutral atom or molecule in the gaseous state to form a negative ion. These electrons are formed from non-metal elements, for example, group 7, which is halogen, form negative ions in ionic compound. Next, the first electron affinity is the energy released when 1 mole of gaseous atoms each acquire an electron to form 1 mole of gaseous negative 1 ions. For example, X atom receives an electron to form X negative 1 ion. The second electron affinity is the energy required to add an electron to each ion in 1 mole of gaseous negative 1 ions to produce 1 mole of gaseous negative 2 ions. For example, X negative 1 ions receive an electron to form X negative 2 ions. So here are the process of electron affinity. What happens in the first electron affinity is negative electron added brought towards positively charged nucleus. Force of attraction occurs and energy is released. The first electron affinity has a negative value because of it is formed from exothermic process. Then what about second electron affinity? In second electron affinity, energy is required to add electron to an already negative ion. Incoming electron is repelled by the negative ion and energy has to be supplied. So the second electron affinity has positive energy value because it is formed from a determinate process. This is an example of a graph about the first electron affinity. The graph shows electron affinity against the element in period 1 and period 2. The electron affinity decreases down the groups and from right to left across the period, because the electrons are placed in a higher energy level far from the nucleus, thus a decrease from its pole. I want you to know that the deep-at parallelism occurs because the added electron goes into an already singly occupied 2s orbital. It experiences considerable repulsion and less energy is released, while the deep-at nitrogen is caused by the extra repulsion of putting a second electron in the singly occupied 2p orbital.